Good evening, everybody, and welcome to BCS Edinburgh branch webinar, DevOps, the Future of Change Management. My name is Mike Hurst from BCS Edinburgh branch, and I'll be handling the technical side of this meeting. So I'll now switch presenters to Mike Long, and while we're doing that, I'll hand over to Seb Rose, who will introduce our speaker for this evening.
Thanks, Mike. So now two mics. I'm saying thank you to Mike Hurst there, and I'm going to introduce Mike Long. So first off, it's a big thanks to Mike Long for stepping in to present on DevOps and change management at such short notice. It's an important topic, and Mike has got a lot of experience in this area. However, I'm going to leave him to introduce his technical background himself. What I would like to say is that Mike's an old friend of mine from an organization, from the days of an organization called ACU, and we've spent many happy evening with a bottle of whiskey in the ACU situation. So what's a real shame is that, Mike, you're missing out, because typically at the Edinburgh branch meeting, when you talk in person, there is a speaker gift of a half bottle of malt. Oh, I know. So we'll have to get you back in person, or maybe when you're in Scotland next, we'll get you something to drink. So thank you very much for offering to give this presentation. I'm really looking forward to it myself, and we'll be doing Q&A at the end. So over to you.
Thanks, Seb. That's really kind words, and yeah, I'd very much like the chance to come and present next time I'm in Edinburgh and meet you all. Thanks for spending your evening with me. I'm sure there's lots of other things you could be doing, so I appreciate you spending the time tonight. I can start with a little bit of an introduction on who I am. I'm a technologist by background. I studied computer science in Scotland. And I spent 10 years in the oil and gas industry building technology, mostly at the low level of systems in the kernel, device drivers, cross-compile tool chains, and networking and so on. But over time, I got more interested in, how teams and how organizations deliver technology. I was very keen to introduce things like test-driven development, continuous integration, hardware in the loop testing, and step by step, I got more into architecture and running teams. And before I knew it, I was in China running a DevOps team that was serving a development project across the whole world, 300 developers. And I'm having a great time, but it was time to end the journey in that company. And we moved back as a family to Norway. And I spent the next 5 years as the CTO and partner of building a DevOps consulting business. So I was helping mostly companies where DevOps was difficult to do succeed. So we'd often be asked to help around training people, reorganizing teams, bringing in new technologies, and the like. And in places where it was more tricky, so a lot of my engagements were for banks, insurance companies, but also automotive, medical, and healthcare providers, these kind of areas where you had specific constraints, often regulatory, often security, that you needed to bring into the consideration. It was a little bit more than the vanilla DevOps story. Yeah, and it was doing that kind of work that I came to see that there was a problem with DevOps, and it was around this story of how we record and manage and control risks and change in an organization. And it was something that there's not a lot of information out there. So I've been working on building this business, Merkely, which is, we're a technology company building tools to help organizations succeed with change management, especially in regulated settings. So today we're not going to talk about Merkely or tools or products. I'm just going to talk about DevOps, change management, and dealing with regulations and high security constraints in a lot of areas, especially. So I know in Edinburgh there's an awful lot of fintech, a lot of finance, a lot of software. So I hope that there'll be a good Q&A session at the end where I can hear some more thoughts from what's happening in your environment, how the different regulations affect you, how the FSA is involved, how you work together with your regulators, your internal compliance, internal security, and so on. So yeah, that's a bit about me. I just normally, when I talk to organizations, they tend to be somewhere in the fintech or part of the spectrum, but not necessarily. But regardless of the industry they're in, it's a problem that nearly every company is facing just now, is that every software is becoming a software company. It's this Mark Andreessen quote, software is eating the world. And that's true. And like, for instance, if you take a bank, for example, the most important thing for the bank in terms of winning and keeping customers was the branch. It was about where the branch was, the staff that were in the branch, and the customers that came in and how their interactions were at the branch. And that's not the case anymore. The winners and losers in banking will be not through anything that happens in the branch. It's going to be based on well, the interactions that customers have on their mobile phone and the browser and so on. And you can see that same story playing out in, well, in finance, of course, but also in retail and lots of different industries. And typically, most companies no longer so worried about the competition, the established competition. They're much more worried about new competition, tech competition, competition coming from Silicon Valley and well-financed venture capital startups. So everybody's got some kind of story around, we need to get good at software. And what that really means is that companies have to have the capabilities of world-class software companies. So it's not enough to think that we have to be as good as our competitors. We have to be as good as Silicon Valley at making software. And that's a tall order. That's not an easy thing to do. So the world around companies is changing a lot, but so is software as well. And you go into a big enough organization, or shall we say an organization that's been around long enough, you'll find software across this whole spectrum, where, systems that were made 15, 20, 30 years ago, running on big servers, maybe even mainframes that are very slow changing, have very monolithic architectures, maybe producing 1 or 2 or 3 or 4 releases a year to these systems. And then over time, as we learn more about how to build and structure and modernize our applications, we're getting more into service-oriented architectures, microservices, functions as a service, AWS Lambda, a lot of very, very dynamic infrastructure, often in the cloud, and the rate of change is going through the roof. So these systems are much more loosely coupled, much more dynamic infrastructure, and the rates of change are just going through the roof. So most companies you speak to, I'm sure this is true for you as well, they've gone through 3 orders of magnitude increase in the change rates over the last 5 years. That's great. I mean, this is all of the reason why everybody wants to move to this right-hand side, regardless of where your technology fits on, or what your landscape technology looks like. Everybody wants to create new technology in this right-hand side, and they want to bring what's on the left side further to the right, which makes a lot of sense, because the whole point of loosely coupled, rapidly updated architecture means that you can meet the needs of your customers faster. This is the whole point. Get over here, you can go faster. So the world is changing, software is changing, but in regulated industries, change management, for the most part, hasn't changed enough, or sometimes at all. And these old ways of managing change, like change windows, change advisory board meetings, manual release documentation, batched releases, these old ways can't keep up with modern DevOps teams. These methods are proven to be ineffective at mitigating risk. So the fact that you have to do all of this is a problem, or at least these old ways of managing risk are a problem when you go faster. And I said in the last slide that there's evidence that this approach to managing risk doesn't really work. And it's true. I mean, the reason why all of those processes were put in place, and often, like if you go back to ITIL standards and so on, they've started with a good foundation or a good reason, a good motivation. And this was, we want to manage risk. And the way we're going to manage risk is by being careful. And we're going to follow our process. and we're going to have meetings, and we're going to make sure we have eyes on the problem, which in theory is quite a good idea. But the problem is that in reality, change management boards, there's no data that shows that they're actually effective at reducing risk. The DORA team have been doing surveys across the IT industry for almost 10 years now, and what they found is that external approvals like a CAD board or an external manager, they had no correlation with change failure rate, in the sense that teams that have a CAB or have external approvals did not see an improvement in change failure rates compared to those that did not. So they simply doesn't work to increase the stability of production systems. That's what they found. However, what they did find is that external approvals and CAB meetings certainly slow you down. So the analysis is having a CAB is worse than having no change approval process at all. You can read more about it in their book, Accelerate. But then you think, okay, well, why are we doing things like this? Why do we have this in the first place? I can say I was doing some work for a bank in Australia. I was building helping a bank establish an engineering practices team. So the idea was that they wanted to build a team inside the organization who would kind of take on an internal coaching role. So this engineering practice team would go in and help the teams look at how they're working and help them improve their tools, their practices, their ways of delivery, so that their cycle times could increase, their lead time for changes could become better, and their stability and quality could increase as well. And while I was there, we went into some teams, and we would start with value stream mapping. So starting from the original requirements or the changes that were kind of put into the value stream, what was asked for from the market, in a sense, how those requirements were broken down, how they were scheduled into work, how that work was coded in the team and qualified and created the release and out to all the way to production. So the whole value stream of software delivery. What we found was that the teams had gone from 6-month releases, like a biannual release process, to a 6-week release, which is fantastic, right? That's a huge improvement. But they had really the ambition to get to daily, hourly, on-demand releases. And the problem wasn't in the version control systems, the testing automation, the pipelines, the deployment. I mean, there was issues there, but that wasn't really what was the bottleneck. The bottleneck was that in order to get a release, you had to cut a new branch 3 weeks before that time, because you needed 10 days notice to get into the CAB meeting, and you needed to produce all the documentation on a SharePoint site, and you needed to schedule the change in the change calendar, and you needed to get everybody involved on the day to come and do the deployment. And obviously, like a good consultant, I said that, well, this is the part of the problem you need to fix. And then I packed my bags and went home. But that wasn't the real challenge they faced, because they were saying, okay, well, we need to do all of this because of APRA, which is like the FSA in the UK, or Finanstilsynet in Norway, or it's the regulating body. In Australia, it was inside the banks. Everybody is following these cargo calls, because the way that they've delivered their change to production in the past has been approved by the auditors. So anything that changes from that or deviates from that is some kind of open question. How do we know that this is the auditors are going to accept this? So it's always easier to add more bureaucracy, more meetings, more paperwork and documentation, but it's even if it doesn't reduce any of the actual risks. So there's some kind of guidance from the regulators, often saying, like, you need a segregation of duty controls, preventing insider threats. So me as someone in the bank can't sneak code into production that shouldn't be there. we have to make sure that everything that goes to production has been verified and qualified before it gets there. That's fine. But to use the same approaches from 1990 to qualify and to document and to manage risk in 2020 just doesn't make sense. We've learned a lot about how to deliver software in that time. And then the other side is, well, what does an audit look like? This image is just a screenshot from the law that regulates the banks in Norway. I live in Oslo, by the way. I don't know if I mentioned that, but you know, there's some the law that regulates the IT systems and finance in Norway is very short. It's really 14 paragraphs, and each paragraph is just a couple of sentences. It's very, very high level and very, very vague. It's not prescriptive at all, and that's a good thing, because if it was prescriptive, it would never be able to keep up and never answer all the questions that needed to be answered. So the actual implementation of the regulatory function is down to the regulators. They're going in and looking at the details and making decisions and passing judgment. That gives them an awful lot of space, but it also gives the companies an awful lot of space, because it means that they don't have to follow an exact prescriptive way of doing things. They can find their path to meet these needs. But an audit, regardless of how you meet these generic needs, always has similar kinds of questions. You know, you must have a defined software development process. That's actually paragraph 6 in this law. So what is your software development process? You must have one, because that's the law. Where is it? Where can I find it? Show me it. And then now you have to prove to me that you actually follow the thing that you've written down. You have to have the evidence that you followed it. And then, you know, it starts to get into more of the details. You know, good auditors will come and say, okay, what's currently in production? What changes were in the last release? What was deployed 17 days ago? What were the last 10 changes to production systems? When did you last have an incident? Who accepted and signed off on the risk of this change? And so on. It's a lot of, you know, investigative work. That's what an audit actually is. And it can be very short and it can be very long, depending on, you know, the needs and how the regulators see the risk landscape in a particular organization. So regardless of whether you are regulated by the FSA, by Finanstilsynet, by APRA, or you just want to meet ISO standards like ISO 27001 or ISAE 3402, or if you need to meet PCI DSS standards in order to be able to handle credit cards. In general, there's kind of all of these different frameworks have the same need. They require every organization to have an IT governance framework of some description, where it says who's responsible, how things are done, how do we manage risk in this IT landscape. And when we get down to the software change management, it's usually down to these 3 things. You must have a defined way of how your software changes. You must have prescriptive definition of how software changes and how you manage the risks that these changes will introduce an issue. Then you need to actually follow that process. You need to implement that process. So whatever you've written down is something that you need to follow. And then the third thing you need is proof. You need to be able to show the auditors, show the internal compliance people, show the security folks that you actually have always done or always followed your process. So the definition, the implementation, and the proof. There's the 3 requirements of your governance progress. So if we wind back the clock 20 years, this is generally what a governance framework might look like in a regulated industry. You know, you have a written document that is your software development lifecycle process. And then it will say how you use version control, how you do code reviews, how you qualify your software, how you make releases, how you do deployments, how you manage issues. All of that will be in some kind of documentation, often on the wiki, but you know, I've seen it in PDFs and other documents too. So you have your process like that, and then you do manual build, qualification, and deployment. The very first job I had at a university was to make device drivers. And one day a week, I would be what's called the baseline manager. And my job was to, in the version control system, cut a release. And that was to go, like, basically get all the versions of all the different files and libraries and so on, package them together, do all the builds, and make a product manually. And, you know, that was 17 years ago, and I think it was still quite common then, before we had Jenkins and so on, that we started to get into this world of CI. And then, of course, you need the proof that you followed that process. So typically the proof would be maybe in your version control system, in your task management system, and you would have manual release notes. Someone would actually, job would be to create a document that says, okay, this is release version 12.16.246. It's been approved by X, it's been qualified by Y, and this is where it was built, as an example. And, you know, we've made software like this for decades. It works to an extent. It works as long as you have a low volume of change. If you're releasing once a year, once every 6 months, once every 3 months, you can get away with a process like this. I mean, you have all the problems with long feedback cycles, of course, but it's a possibility. It will work. But these days, of course, we have, you know, the broad adoption of DevOps and CI and CD in the organizations. So what I've seen is more common, well, actually more or less universal in most companies in the regulated spaces, that we still have the process on some kind of website, some documentation website, a wiki or such. And we still have a lot of manual release documentation, minutes, and so on. And in the middle, this implementation, like, of how we actually do our software development is for the most part managed in the DevOps pipelines. Because in the pipelines, really you're connecting your code reviews, your version control, your build, your test, your deployments, and so on. A lot of how you make software is contained in your pipelines. And this also is quite good to a certain extent. This approach will be fine for medium volume change. So you can, like the bank I was mentioning, you can get to medium change volume. So when you're thinking of smaller teams releasing every month or so, that's about as fast as you can go, because there's a cost to making the documentation and the release and manually getting the last mile to production. What it looks like is, from a lead time perspective, is that the teams themselves, the technology teams, can build and qualify their software in relatively fast cycles. But until the deployment comes, you don't really get that feedback. And to get to the deployment, you have to go through these ceremonies around change advisory board, the release documentation, and so on. And that bottleneck leads you to build up higher batches, longer lead times, and essentially have higher release risks. By risks here, I'm talking about the change failure rates, and the mean time to recovery tend to go up the bigger the batch sizes. So what we're advocating for these days is something called DevOps change management, where you actually define a lot of your whole governance framework as code. So you define what your risk controls are, you define how your audit trail is, you define everything about, well, as much as you can define about your process, you do it in the pipeline. And of course, there's still need for human in the loop controls. You still need someone to, for example, accept the risks of a change to production, or do someone to actually do the code review. These things have to happen by people, but the proof that these things happened and the generation for the documentation can all be automated. So this approach is an extra step, but if you get to that, you also get this benefit of live documentation, because from your pipelines you can generate what your process definition actually is, and you can do it on a pipeline by pipeline basis. So one of the things that I see often in big enough organizations is they have a software development lifecycle or a software process written down, but because there's so many differences between the teams, different technologies, different locations, different tools, different stacks, one process doesn't fit all. And therefore, the process tends to become more and more generic over time. And the drift between what's written on the process website and what each team is actually doing gets higher and higher over time. So what a DevOps change management approach does is it kind of flips it on its head. It says, okay, we can define this stuff on the pipeline by pipeline basis. We can extract a lot of this stuff. We know how version control works. We know how the risks are controlled in the pipeline. We can generate the audit trail. Let's also generate the live documentation on a pipeline by pipeline basis. So we can start to actually infer things across all the pipelines, regardless of the different CI tools, the different technologies that people are using. And we can start to do interesting things like say, okay, what teams don't have security scanning? What teams are doing deployment logs, for example? And you can start to see that across all of your tooling. So this is kind of what we're aiming for, this world of DevOps change management. And like if we visualize that value stream again, the lead time for changes goes down because what we're trying to do is we're building this continuous compliance into every change. So we're not waiting until like trying to glue on change management at the end of our work. We're building change management as a continuous process into every single change. And if you do that and you manage risk on a change by change basis, if you're doing trunk-based development and you're getting all the risk controls and you're building the audit trail you need, then deployment can be a business decision rather than one based on the administration side of things. I'll just skip this side, but this is just a kind of a comparison index of the different approaches. So that sounds fine on practice. How does it work? You can do this in lots of ways, and a lot of companies have succeeded in doing this in the past. Like there's some great examples in DevOps, like ING has been very successful. Capital One, who I mentioned earlier, they've done an awful lot around building this compliance into their pipelines to allow the teams to both the freedom to deliver, but also the building in that control that they need. One of the, I mean, I've spoken a lot about process compliance in this talk, but there's also another kind of almost more important aspect of a lot of these governance frameworks, and it's often comes under the section around security or so on, but really what they're talking about is insider threat. Google has this really good, shall we say, quote about how they think about insider threat. And they said, we want to do as much as we can to minimize the potential for Google personnel to use their knowledge or access to user data in an unauthorized way, including running an unauthorized job. So what they're saying is, they go on to say in this article actually that this is important, obviously, in case you do have someone on the inside that's a problem, but it's also important if you're somebody on the outside happens to just steal the credentials or a laptop or has some access from an insider. And managing this insider threat is really important, and especially when you're dealing with health data, with financial transactions, with some very sensitive information. You want to be able to really prove that you've got this under control. So, I mean, that's also one of the reasons why nearly every regulated company in their process will mandate release approvals and code reviews on every change, because it's the only way you can be sure that at least other people have seen what's going on. So to do this in a DevOps world, what you want to do is to build like a secure chain of custody across your value stream. the way we recommend it is to use, in the end, what you want is production to be the only workloads running in production to be workloads that you know about, that have some kind of provenance that you can be sure of, that have gone through all of your risk controls. So in your pipelines, if you say we have to make sure that this change has been code reviewed, that we have done security scanning, we've done dependency scans, we've run the acceptance test and the performance test and so on. Whatever you say is your risk controls, you have to make sure you've got the evidence for them. And if that's true, if everything in production has been there, you know about it, it's been approved and is compliant, then you've solved an awful lot of what is required from a governance perspective. So if we take it from the point of view of the start of the software delivery process, in the DevOps world, you say the delivery starts from really when the commit lands on a central server. So that's usually when you build a software package. So the very first thing we want to do is to make sure we build binary provenance into our systems. So there's a lot of ways you can do this. You can have a lot of security around your artifact management systems. But what we found is the kind of the easiest way to ensure binary provenance is make sure that in your pipeline, you take a fingerprint of everything you make. So if it's a Docker image, you might take the repo digest, or if it's a jar file, you might just take use OpenSSL to take a SHA-256 of the bytes. But anyway, you want to be able to get a unique fingerprint that can only identify this binary. And also that if any bytes in this binary should happen to be tampered with, you'd get a new fingerprint. So what this means is that anywhere this, and then you want to store that fingerprint somewhere. So typically you say, from this git commit and this build, I produced this artifact with this SHA. And that means that anywhere you want to add evidence to the qualification of this artifact, or make approvals or deployments, you have something that's kind of incontrovertible. You can't argue with the SHA. So after you've got this fingerprint, you want to store this somewhere, and then you want to start to build this kind of paper trail of the control evidence, because from an audit perspective, you want to be able to go back in time, and you want to say, okay, for any given artifact, we want to be able to know that we've had the qualification data for it. It could be that all exists in a pipeline in your CI system, but and that's fine as long as you can manage to keep that data around. Now, that's not always true in CI systems. Often they're very dynamic. The pipelines come and go. Pipelines are renamed. They have retention policies. They're not usually considered to be an essential database, and the data isn't often secured from the mindset of audit trail. But anyway, you could keep it in the CI system, you could put it in Git, you could use obviously tools that we provide. But anyway, you want to be able to build this kind of trail of history for every artifact that goes through your system as it's qualified, as it's approved for release, as it's deployed. And ideally, you want to keep that in a format that you can use in your pipelines. It might be JSON, it might be any kind of format, but you want to be able to actually make decisions in your pipelines based on this data as well. As you're getting closer to production, you will want to release something, of course. Someone will make a decision that this should go out into production. Very often in a DevOps world, what this means is pushing a Git tag, pushing a branch, or even pushing a button in the CI system. But that's not enough as an approval from an approval perspective, because what you need to do really to have this segregation of controls is the person pushing that approval must understand the changes, and they must not have created the changes themselves. So there's some, shall we say, there's some interesting challenges around how you do approvals in your pipelines. But anyway, the creation of the approval should be automatic. It should be possible to create the report that someone can sign off on, or people or groups can sign off on. And then, of course, we get to deployment controls, where you say, before I deploy this piece of software, do I know about it? Have I got the thing? Do I have a record of this binary with this fingerprint? Has it been approved? Do we have all the control evidence? If not, we're not going to do the deployment. But if we do, let's do the deployment and log the results somewhere. And if you get good at this stuff, logging every single release, every single deployment, every single piece of evidence, controlling your risk, building this secure chain of custody across your pipelines, means you can get rid of a lot of the manual processes around release, and you can stop batching so much in your DevOps approaches. So I'm getting towards the end of my talk now. I just want to say that we are, my company, we're doing a lot around DevOps change management. We're building a DevOps change management platform. So we have a lot of tools and opinions about how this stuff can work around secure chains of custody, risk controls as code, provable audit trails, real-time process documentation. But you don't need to use our tools. You can do this all yourself. And so a lot of companies have done this themselves. So there's a lot to learn out there. But I would say this last point is the one that I think is the most important, regardless of how you get to solve this DevOps change management problem, is that what you're really trying to aim for in the end is empowered teams. And in the world of DevOps, an empowered team actually means something. It means a team is not dependent on another team to deliver their work. So the classic example is the development team isn't dependent on the operations team to deliver their work, because there's dev and ops in one team and they're delivering together. Now, of course, the concept of DevOps has expanded a lot over the years, and what that really means as an empowered team is you need to have development and operations and QA and security, and yes, even change management. Whatever you need in order to be able to deliver safely and according to your requirements, that should exist inside the team. And that can only happen if you empower the teams to do so. So you can't really solve this problem unless you're really looking at this from a cultural and an organizational perspective as well. So that was what I wanted to talk about today. I don't know exactly how this works around QA, and so I maybe Seb, you can say something, or Mike. But anyway, I just want to say thanks for your time. Really appreciate the opportunity to talk to you, and I'd love to stay and answer some questions. I will be around, and hopefully I'll see you next time I'm in Edinburgh.
Thank you, Mike. Unfortunately, you'll not hear everybody clapping because they're all muted, so I'll clap for them. Thank you very much. We already have one question, and it's from Jorge, and he asks, is this a blockchain app?
Ah, very interesting. Good question. It's not, but it's very close to a blockchain app. We did look at blockchain. We looked at lots of different ways to store this data. I mean, you could do it with blockchain, but what we decided at the end was the best approach was to use Git, because Git, just like blockchain, is using Merkle trees. That's where we get our name from, actually. And a Merkle tree is just a kind of a hash chain. So it's an append-only journal in that sense. So you can only get to the next commit from the sum of all the previous commits. And so what we realized is that Git is giving us basically a non-distributed, a centralized, which is what we wanted, a centralized append-only data store that is provably append-only. And so, I mean, you could also do this with blockchain. There's nothing in the world to stop you, but we felt that Git was easier from the perspective of the DevOps tool chains as well. And it's something that all of the DevOps teams understand and can integrate well with. So, no, it's a good question, but you could do it with blockchain, but we decided that Git was a better solution.
Thanks. So we've got another couple of questions typed in. However, earlier on in the talk, a gentleman called Ali Abdallah asked to go interactive. Ali, if you still want to talk, please click the raise hand button, and that goes for everybody else that's listening as well. If you would prefer to ask your question directly to Mike rather than me read it out, you type it in, me read it out, and maybe mangle it, then please just click the raise hand link. So Ali, I saw you raise your hand and then take it down again, so I'm not sure if you want to speak. So I'll move to the next written question, which is from Deborah Bradley. And she asks, how is the documentation produced? Is this automated somehow? I'm thinking in the traditional way, docs are created after the fact and often don't get delivered because the developer is focused on the build.
Yeah, I mean, that's a good question. Yeah, so for us, there's kind of two flavors of documentation. One is the documentation of the process, which is the way we do it is that we ask the developers to actually define their process as code in the file. This sits next to the pipeline code that tells the world how they make this, what their process is essentially, like how version control works, what controls are in place in their pipeline, and what kind of evidence we should expect for any given binary, or what kind of control evidence we should expect. So we use kind of the developers, we're in the developers' perspective of how to define this, just like they define their pipelines and they define their Docker images and so on. It just sits neatly in their repo. So, and from that, we generate documentation that actually is kind of human readable, because what we found is that the developers are actually quite good at managing risks in general, but not very good at documenting their systems. But in general, the documentation is the same. Like, I've been to many organizations now, and what they have on their documentation processes, it's more or less the same. Like, this is how we use version control, this is how we test, this is how we do this. And what we realized is that, okay, that human readable, the stuff on the wiki page isn't there for the benefit of the team. It's there for the benefit of all the external stakeholders. It's a boundary object, if you take the social anthropology perspective on this. So that's something we generate in our tool based on the pipeline definitions, or the pipeline definition file that they give us. We generate the process documentation on a pipeline by pipeline basis. Then there's the other type of documentation, which is around documenting the changes that are happening. What's going out to production, what was the last release to production, who signed off on this, who signed off on that. That's also an audit trail that we generate automatically from the pipeline events that occur, and also the kind of the CI and Merkely approvals that occur. So there are two different types of documentation, and in general, we're kind of optimizing for everything that's repetitive and can be automated, making a nice and simple way to do that.
Thanks. Right, I'll now go to Ali Abdallah. Ali, I've allowed you to unmute yourself, so could you unmute yourself by clicking the microphone icon and then ask your question? Over to you, Ali.
Hello, Mike. It was very interesting and very useful talk. What I wanted to ask with regard to documentations and server management and version developments, when in the wake of the new Brexit due restrictions, do you see anything that we should look out for? Thank you.
Thanks. That was a good question. So I'll take them as two separate questions, if you don't mind. Around server documentation, we don't actually have very many opinions on this in Merkely, and I'll explain why. So most of the tech teams we deal with are building software that's going to production, and that's running on some kind of platform. It could be a Kubernetes cluster provided by a cloud provider, provided by IT systems, and so on. Or they're generating their infrastructure using code, like by using Terraform or something like it. In the sense that if you have an automated pipeline, we believe that we have the same process around change management. It's just that what's going through the pipeline is the change to your infrastructure rather than the change to a software package. And we treat it in exactly the same way. But when it comes to more traditional IT landscapes where you actually have you have servers that have versions that are patched and maintained by an IT department, I think that the traditional ways of dealing with these traditional types of IT are better. Like, you have your IT service management tools, you have, like the tools like, well, some organizations are using Jira, but others are using ServiceNow and other tools like this. But I think that when you come to more traditional server management, then there's a lot of tooling out there that's already kind of helping in that space. Did that answer your question?
Yes, in a way. Just one little thing wanted to clarify it a little. So, when it comes to change management, do you see the actual or the pandemic have an effect on our DevOps operations in documentation and due restrictions of geographical due restrictions and all that? You kind of answered it before, but it's just to be very specific. The translating the political change into codes or documentation.
Yeah, so around the pandemic, I can say a few things about that, especially I think that I've seen over the last 6 months. It's been very interesting. And that's what's happening is it's a lot harder for internal governance teams. Like it could be, in Norway, it's quite a common, I don't know if it's the same in Scotland, but in Norway, there's a very common framework called the 3 lines of defense around managing compliance and risk around IT. And the first line of defense is the line management and the teams themselves, keeping an eye on things, making sure that they're managing their risks. And then the second line of defense is the internal governance functions, which can be IT change management, it could be security teams, it could be IT compliance organization. There's usually some kind of internal regulatory part of the organization, making sure the others are doing what needs to be done. And then the third level is the regulators. Now, this second level of defense, they're really struggling just now, because without good tools to understand all the different teams and all the different systems and so on, whereas before they could walk around the building, talk to people, navigate around, it's really hard to do that these days. It's really hard to find out, what software is changing lately, who's changing what's not being changed, what controls are in different parts of the building. It's much harder, this internal governance function now, and we need better tools around kind of uncovering what your true landscape is. So that's part of it. And then around your question around, how did these new regulations, tracing them into the systems and so on, I think that's more muddy as well. I think it's a harder question to answer, because sometimes it's it affects, for instance, like GDPR is something that you should kind of consider on every single change somehow. How does this affect personal data? But actually enforcing that and seeing how that gets translated into code and so on, it's not an area that I have spent a lot of focus on, so I can't say much about. I'm sorry.
Thanks, Mike.
Yeah.
So I have a question from Ian Thompson typed in, and in fact, I've got two, so I'm going to pick one of them. It says, how does risk assessment of change occur in DevOps approach in terms of change causing possible business failure? And he clarifies he's in healthcare, so avoiding harm is essential.
Yeah, I think there's a lot. I mean, I kind of glossed over it, but like software organizations that are regulated because the consequences are so high. Like we're talking about the economy of the country, we're talking about people's lives, you know, in the case of healthcare and automotive, and you know, there's the reason why that these very high standards are required is because there's very big consequences if things don't go right. So what we've generally found is that the best way to manage risk is to make sure that you reduce any kind of risk that you have in your development process as much as you can. So there's lots of ways you can do that. Like, and a lot of shall we say ITIL organizations I go to, we have a big focus on how do we get to the world of standard changes, where change is just an everyday part of the business. It doesn't require a CAB meeting and a risk assessment and so on, because we know it's a small change and it's very easy to back out and it's tested, and that if something does go wrong, the blast radius is relatively small because we've got feature flags or we've got, you know, other kinds of risk mitigation strategies. So the idea is not to deal with, like, you know, how you score and manage risk, but it's like, how do you get into the habit and culture of reducing the risks of changes over time? Because that's really what you need to do DevOps in a highly regulated industry. You need to say, okay, how do we get there? Well, first off is that we do the risk assessment before we start coding, not when we're about to release. That's the wrong time. We should do it on a change by change basis while we're kind of crafting the requirement, like while we're discovering the work, what we need to do before we start coding. And then we, you know, if it is a high risk, we need to figure out, well, how do we manage that? How do we reduce the risk? How do we slice this? How do we take this in smaller steps? And then, of course, there's a lot of tooling around how you deal with this as well in the modern day, like what kind of chaos engineering, what can we do? What kind of ways can we back out of a change if it doesn't work? You know, the great thing about automated deployments isn't that you can do automated deployments, is that you can roll back deployments really easily. Like if your time to changing production is a few seconds, then you know that, you know, if something should happen to go wrong, you can go back to the previous release within a matter of seconds or minutes. And that gives you an awful lot more leverage when it comes to, you know, going faster.
Yeah, thank you. I think I'm just going to interject there and saying possibly in healthcare, being able to roll back in a few seconds may not be good enough for every healthcare situation. So I mean, there's obviously also in your DevOps pipeline, you can have a verification of specifications. You could have enforce it, sign off on the specifications and the automation and execution of those specifications. So there's a whole bundle of stuff that you can incorporate into it. So the wonderful thing about so many hype words, and DevOps being one of them, is that it becomes a thing of its own. Whereas really, you know, DevOps is, as you've described, is about this automated pipeline. And actually you can put pretty much anything into that automated pipeline. You don't just have to focus on the build part. You can also incorporate automated testing and the like.
Yeah, absolutely. And that's what I really mean when I talk about automated risk controls in the pipeline. It's all of those things that we can do in the pipeline that can help manage the risks. And I agree with you, Seb. I mean, some things, like if you're making a pacemaker or, you know, some medical devices and so on, you're not doing continuous deployment to air traffic control systems, right? Because, you know, that's not the way to do. I mean, that's a risk level that doesn't make sense.
Yeah.
And I do some work in the defense industry as well, and it's the same thing there. You know, there's a lot of places where, you know, you just don't roll out changes. But there's there's a huge part of the software industry where really it is not, you know, it's not, there's some there's always going to be some risk in software. So, but the existential risk of not being competitive is somewhere in the landscape of needing speed, and that's usually where I do the most of my work.
Thanks, Mike. I would like to go to yet another Mike. Mike Ritchie, you had your hand up. I have just enabled your microphone. Over to you, Mike.
Excellent. Thanks very much for the talk, Mike. That was great. So I've got a question following on from the SolarWinds hack. I'm sure we've all been following that to some extent. There was a theory that the SolarWinds hack was caused by a supply chain hack introduced by a compromised CI server. I believe it was Team City, I think, was the tool that was being discussed. Now, after that, I was trawling around a few forums, and there seems to be quite a lot of nervousness out there about not DevOps per se, but the complexity of the machines that we're building to effect this change, and that certainly resonates with my experience at a few companies. You have half a dozen different software as a service platforms, you have proprietary CI platforms, you have some open source stuff in there as well. So how do you reassure people that this very complex machine that we're building to build our software and get it into production, which is now almost rivaling the complexity of our production platforms themselves? How do we manage that? Do we have to take these same change control approaches and apply them to the machine that we're using to effect change, as well as the stuff that we're rolling into production?
Yeah, thanks, Mike. That's a really good question, actually, and it's been I mean, this is an old problem in computer science. There's this famous Turing Award lecture. I forget who it was that gave it now. The name escapes me. But around trust, it's called On Trusting Trust, and it talks about, you know, if somebody can hijack your compiler, then there's nothing in the world that can save you from any kind of security risks in your software. Whatever you're building, your whole tool chain is compromised. And we have this across our whole suite. And this is also why dependency management is really, really important. It's something you need in your pipelines if you're at all concerned about security. Because, you know, I mean, as an industry, we're relying more and more on open source components in our tools. Open source is great. It's been like the amount of code we don't have to write these days is just phenomenal. And I say this as someone building a SaaS software company. You know, cloud technologies, we've got open source frameworks, we've got so much free, good quality technology that we can just use. It's great, but you have to be really careful about your supply chain, because, you know, you don't know what's coming down when you pull a Docker image. Really, it's really hard to be able to verify the contents of this. And Debian's got a really interesting project called Verified Builds that I'm really supportive of, where they're basically building binary reproducible packages. So basically stripping out all the timestamps and anything that's non-deterministic about the build system, so that, you know, you can take the same git commit snapshot of the source code, run the build, and you should have exactly the same SHA of the binary at the end that they're producing. And I think that the future for open source has to be down this path. I don't know if there's another way that we can solve security without getting serious about binary provenance. And for the most part, that's going to be about binary reproducible builds.
Thank you. So we are at time. Mike, this has been a really interesting talk. Thank you very much for coming along.
Thanks for having me. It's been really interesting. I love the questions as well.
So of course, people can get in touch with you on Twitter, or they can email you at the Merkely email address. And no doubt you'll be coming back for the whiskey at some point once the flights start. So
you bet. I'll be on the first flight to Edinburgh.
Okay, thank you very much. Thanks everyone for coming along, and we'll see you in April, where the president of the BCS will be talking to us, which will also be interesting, but probably not quite as technical.